All right, welcome back to Lag Demon Programming. I'm Bill Westlake, and we are working on compiler design. In the last video, we had one small error. It wasn't processing our new tuple structure quite right, and that is because I put the tuple here under R value, and a tuple is actually an expression, and an R value is also an expression. So that's fine. A tuple will become an expression. A tuple is also an R value. We've got that listed because it's part of expression, so it's also an R value. That's the way that works, and all we have to do is transfer it in once it's created. So all I did was move this line right here from this R value group up here to our expression group, and just make sure it's built. It is, and if we run it now, we see that our entire tuple came through. 1, 2, quote, quote. This is a string, a tuple, 42.5. And I probably should put strings back in quotes and stuff like that, and maybe even unescaped strings as well, putting the values back in. But I'm not going to worry about that right now. We can see that it's working. Over here in Pretty Print, I fixed it just a little bit. What I did was I get the length of the actual set of R values that are in there, and I put that in, and I had made a test actually and I think I didn't change it back. I was checking to see if a tuple was being processed correctly or being found correctly, and it didn't seem to matter, and I had added this tuple token in here. You can see that what I did here, test. I said tup at the beginning of it. That's a keyword that I created for it. It certainly, I don't know if I like that or not. I think I'm going to take that out and see if it still works. If it doesn't work, we might have to put it back in or re-examine our syntax a little bit. So let's take that out. Let's take it out of here. So it's just this. Oh, and there's another thing we got to do. This can't be $3 now. It's got to be back to $2. Let's make, and let's run it. I think it maybe collected it. It did. Oh, so it worked fine without that. So I'm going to take that keyword out of the lexer as well. We don't need this. And I'm going to go back to here, and I'm going to take the keyword out of here. We don't need this. And we'll do a make again, just to make sure, didn't mess anything up. And there, it's working just fine. There's our tuple. Okay, so it is picking up tuples now, based on values that we put in, or they could be identifiers in there as well. And let's check that. Let's see if it can be an identifier. Let's go over to here and put something like an identifier. And there's an identifier. So pick that up as well, and put it out. So I created a little in messing around here. I don't remember if we did this in the last video or not. We got our little Fibonacci function here. We can eventually hopefully compile, and it'll actually compute Fibonacci numbers if things work right. We're going to have to set up so that it can be recursive as well. That'll come later when we start doing the visitor processing and so forth. Okay, I'm back. Sorry about that. I forgot to set my timer. I wanted to see how much time was actually elapsed. I got my timer running now, so we won't go terribly over. So that's a tuple. Now the next thing that we have is a list, and we want to make a list, something like my list equals, and a list differs from a tuple in that they all have to be the same type. So we can make a list of integers, but our compiler isn't actually going to check that. We're going to have to check types later. It complicates it to do type checking in the parser. So we're going to check the types afterwards, but we can have my list and let my other list equal It could be something different like 3.5, 4.5, and 42.2. So they've got to be the same types within them, and we'll check those with a visitor and emit errors if they're incorrect. We'll do that in the second stage when we start working with figuring out the types and assigning things and moving things around. So let's go to our parser and do something similar. Although I think with the list, do we want to do commas? Yeah, I rather like commas rather than like semicolons for a list. So I like to have a space after a comma. It's just a little easier to read. All right. So back in our parser, very similar to what we did. The only difference is a list can have no elements. Unlike a tuple, it doesn't make sense to have an empty tuple or a tuple with one item. But it does make sense to have a list with no items for very important reasons, which we'll get to when we start processing lists. So here's our list, or here's our tuple. Let's do a list now. It's just going to contain an R value list, or it can be empty. So let's go what a list is. So a list can be a open brace, or no, an open bracket. Do I have bracket? Did I create that? I don't think I used those. Where's our Lexer? Let's move it over here. No, I don't have bracket. So let's do this. Quote one of these. And we will return O bracket. And one of these, and we'll return C bracket. Make sure those are spelled right. And we'll go over here to our parser, and where we have our these things, we'll just put it down here. There's O bracket, and this one's C bracket. So now we can go down here for our list and have an O bracket followed by an R value. Oh, well, it could be an O bracket followed by a C bracket. So this would be an empty list, or it can be an O bracket followed by an R value list followed by a C bracket. So that's our entire list. And in this case, we're just going to be saying something like $$ equals new list, like this. And here we're going to say that $$ equals new list $2. And so let's go create a list. Now a list is also an expression, so we're going to have to work out those types. We'll do that when we come back to this. We'll go over here to our AST again, and right here below tuple, in fact, I'm just going to grab this because they're almost identical. This, however, is going to be a list. It's going to have an R value list. This is going to be list. And R values. All this is good, except also we're going to have list where we're going to say that :_R values equals R values null pointer. Okay. So that's an empty list, so we'll have to check for that. Actually, what we could do is just have this be a valid pointer but be empty. That would be better. So what we'll do is we'll say our values is new our value list. That way we don't return a null pointer from this. It's just got an empty list in it. So now we go back to our parser. We got to set up our types. We'll come up here. We've got tuple. We want to have list pointer list. We can have percent type list list. Back down here to list and new list semicolon. I think we have it. And we got to do the visitor thing next. So let's go ahead to visitor.h, and here's tuple. So we'll just copy this, paste it, and change this to list. We will go to there's that visitor.h. We have to do the except for that, so we can do oops. And this is going to be list. Gotta have that. And then pretty print. We're visiting a tuple. We're going to do essentially the same thing here, except we're visiting a list. So this is going to be list pointer. And we'll make this a bracket. And we'll make this a bracket. And everything should work. It looks like things compiled and didn't spit out. Why didn't they? Oh, I know why. Same mistake as well. In this case, I just left it out. We have to come up here to expression, and we have to go, it can also be a list, and we just go $$ equals $1. Make and did it print them out? It looks like it did. So now we have our lists. So there's our tuple. Here's our lists. We got a couple of lists. So those two things are working. Now we have a couple of different concepts. We've got lists and tuples, which are also nice. We also want to have a couple of user-defined types. So I think we're about 15 minutes into this. I don't have time to do either of the user-defined types all together. So I think we're going to make this just a little bit shorter than usual video. And in the next video, we'll do a record type, which is a very important type. It's like a structure. It's structured data. It's got named fields and so forth that can be accessed. And it can also be something that can produce a scope. So I think we're going to call this video off at this point. So it's about 15 minutes. Yeah, I'm going to need more than 15 minutes to do one of those types. So yeah, that's it. Thanks for watching. I hope you liked it. If you really liked it, hit that like button. And if you really want to subscribe, I really appreciate it if you subscribe. It's very important to me, and I appreciate your time and your effort in watching my videos, and I hope you're getting something out of them. So please subscribe to my videos, and if you want to get updates when I upload videos, hit that notify button. Thanks for watching, and I will see you in the next video.